Alrighty, hello everybody. This is the video for Lab 5. In this lab, you absolutely need StatCrunch. This entire lab basically will be done using StatCrunch. We're going to be doing simulations. Okay, so this is Chapter 7 material, Lab 5, Chapter 7 material. We're going to be looking at sampling distributions. So we're going to be using StatCrunch. We will generate some populations, and then we will be repeatedly generating samples from those populations. Okay, so let's take a look at some populations. So the normal distribution. We call the normal distribution a standard normal distribution. You may not have seen this in lecture, but if not, that's okay. A standard normal distribution just means that the mean is 0 and the standard deviation is 1. If that is the case, we have a standard normal distribution. So this curve over here on the right represents the entire population. We might be looking at all students or all males or all females. But what happens as we sample from this population? That's what we're going to be looking at. So we already have seen the normal distribution. We're familiar with this. Okay. We're also going to be looking at something called the exponential distribution. Now, you're not going to need to know all of the properties of these other two distributions. Just know that the exponential distribution is right skewed. And so it's not like the normal distribution. It's not symmetric. We see this longer right tail. So this is the exponential distribution. We're going to use an exponential distribution with a mean of 1. So here, the mean is 1. For the normal distribution, the mean was 0. And then the standard deviation was 1. And then we're also going to look at something called the uniform distribution. Now, the uniform distribution is also called the rectangular distribution. And so, yes, it is symmetric, but it's not a bell-shaped curve. So every equal-sized interval has the same probability of occurring. It's equal slices. So if we look at a slice of size 0.2, and we're going to use the lower limit of 0 and an upper limit of 1. So the lower limit is A, the upper limit is B. What this means with a uniform distribution, let's say we're going to use an interval of size 0.20. If I cut these slices of 0.20, all of these probabilities are the same. Now we have 1, 2, 3, 4, 5 intervals, and it's equally likely that we land in any of these intervals. It's equally likely. So everything under the curve is equally likely. Every point is equally likely. Okay. And the mean here would be 1/2. Just the direct middle. Symmetric, so it's the direct middle. Okay. We know, so we're going to be looking at sample means in this lab. Sample means and standard errors, sample standard deviations. The sample mean is a random variable. When we draw a sample from a population and we calculate the sample mean, that is just one possible value for the sample mean. The population mean is fixed. That's a fixed value, right? When we pull a random sample, that's a random process. So when we pull a sample mean, when we pull a sample, then calculate a sample mean, that is one possible value for X bar. A sampling distribution shows all possible values for X bar, right? Based on a sample of size n. So a sampling distribution shows all the possible values for the sample statistic. This last sentence, we know this here. This is called the central limit theorem, right? So we have various population distributions, the entire population. As we start to sample with a larger number of subjects, the sampling distribution will start to resemble a normal distribution. The population distribution will not have to be normal, does not have to be normal. But the central limit theorem says the sampling distribution, not the population distribution. The sampling distribution will start to resemble a normal distribution as n increases. So these sampling distributions, these are all the possible values for x bar. And these sampling distributions are centered at the population mean. That is a key fact of a sampling distribution. Okay, I'm not going to go through all of the methods for this lab. It's all simulations using StatCrunch. Carefully follow the methods in the lab manual, and then you'll also have a printout that your lab instructor will give you, a handout your lab instructor will give you. Your lab instructor will be helping you. You're going to simulate values from a normal distribution. You'll have an exponential distribution, so an exponential population, a normal population, and a uniform population. And start with the normal distribution first, and then, so do everything with one distribution, then move on to the next, then move on to the next. Okay, from each of these populations, so these are the populations, you're going to pull random samples. You're going to pull random samples. So first, you'll start with a random sample of 2. So you'll pull 2 values from each distribution. You'll calculate the means. You'll do this many times. You'll calculate all of the sample means, and then you'll plot those. And then you'll do random samples of size 30. Then you'll do random samples of size 30. Calculate the sample means of all of those samples, and then make a histogram. And you'll see what happens. You'll see what happens. So you'll do this for all distributions. You're basically generating a bunch of sampling distributions. You're increasing the sample size. You're taking a lot of samples. You're going to be taking 500 samples. Remember, n is the sample size, not the number of samples. So each time you'll take 500 samples of size n, and n will either be 2 or 30. So make sure you carefully follow the methods. You're going to be getting a bunch of different sampling distributions. Keep these saved in StatCrunch so that you can easily compare once you get to the discussion questions. You will put your results in tables 5.1, 5.2, and 5.3. And then you will answer the discussion questions. Think about what happens to the sampling distributions as n increases. When n is 30, your sampling distributions should look some way. They should look some way. This one is probably the most involved as far as simulations in StatCrunch. So again, just make sure that you're careful following instructions. And if you do something incorrectly, it's very easy. You can just start on a new workbook, a new sheet in StatCrunch. So if you make a mistake, that's totally okay. You can just clear everything out, but just make sure you follow the instructions carefully. Alrighty.